Okay, good morning. Today I'm going to go over section 18.4. 18.4 is about addition and subtractions of radicals. So first we're going to start with definition of like radicals. So what are the like radicals? So like radicals, two radicals terms are called like radicals if they have the same index and the same radicand. So example of like radicals will be square root 3 square roots of x and let's say 2 square roots of x. Okay, so they are like radicals because both of them, they have the same index, which is 2. And when they say the same radicand, radicand is x, which is the number under the radical. So they are like radicals. Okay. Now, what we can do with like radicals? So like radicals can be added or subtracted. By using distribution property. So let me give you the example. The way I put it here, 3 square roots of x plus 2 square roots of x. So we have like radicals, so we can add them. So how are we going to apply the distribution property? Okay, we're going to distribute the radical of x outside of the parenthesis, and we're going to add the numbers which you have in front of the radical. So this is 3 plus 2 square roots of x. Okay, and that will just give you 5 square roots of x. Okay, so let's do a couple examples to practice. Add or subtract as indicated. Okay, so we have two problems. 5 square root of 6 minus 8 square root of 6. That will be equal since both of them are like radicals. So we definitely can subtract them. Outside of the parenthesis, you will put square root of 6, and that will be just 5 minus 8. So we're subtracting the numbers which we have in front of the radical. So we end up with 5 minus 8, which is negative 3 square root of 6. So this is the solution. And let's do one more, B. We have square root of 10 plus square root of 10. So here we're going to use the distribution property. We're putting the square root of 10 outside of the parenthesis. And now in front of square root of 10, it's 1. If you don't see a coefficient, it's just 1. And in front of the second square root of 10, it's also 1. So we have just 1 plus 1. And that will give you 2 square roots of 10, which is the solution. Okay. So we're not adding numbers under radical, we're just adding the coefficients in front of the radical. Okay, so note to add or subtract like, because we only can do that with like radicals. Add or subtract only coefficients in front of radicals. And keep the radicand without any changes. So like we did here in example A, we add the coefficient, we subtract coefficients only, which gave us a -3, and we kept the radicand, okay? So you don't change that, it's still square root of 6. Okay, so let's continue with more examples. So this is example 2. We also going to add or subtract. Okay, add or subtract. So first problem, it's 5 cube root of xy minus 3 cube root of xy plus 7 cube root of xy. So to be able to add or subtract them, I need to check if I have like radicals, which yes I do, because all of them has index 3 and the same radicand, which is square root of xy. So we definitely can add or subtract them using distribution property. So outside of the parenthesis, I keep the same radicand, which is cube root of xy. So you just copy that once. And we only work with coefficients. So that will be 5 minus 3 plus 7. Okay. So that will be 5 minus 3 plus 7. And that will give us 5 minus 3, 2 plus 7. We're having 9 cube root of xy. Okay, so that's the final solution. And let's do example B. We have 5 over 6 y square root of 2 plus 1 over 4 y square root of 2. Okay, so the same thing, we have like radicals, square root of 2 and square root of 2. So let's add them using distribution property. So parenthesis, outside of parenthesis, you putting that square root of 2. And inside of the parenthesis, we putting the coefficients in front of the radicals. Okay, so that goes inside right here. So that will be 5 over 6 y plus 1 over 4y. So let's simplify that. So we have, again, fraction 5 over 6 plus 1/4. So you need common denominator, which will be 24. 24 divided by 6, 4. 4 times 5, it's 20. Plus 24 divided by 4, it's 6. 6 times 1, it's 6. So that will be 26 over 24. Simplify, reduce each by 2. And we're getting here 13 over 12. So here we'll end up with 13 over 12 y square root of 2. That will be the final solution. Okay. Next, what we're going to do, we're going to simplify the radicals first and then add and subtract them. Okay. So example 3 will require a little more work. Okay. So example 3, we may not see the like radicals. That's why we'll need to simplify them first and then combine them. So simplify the radicals and add or subtract as indicated. Okay, so let's do example, the first one. Square root of 75 plus 2 square roots of 3. So right now, when you see this example, you may not see like radicals because we have square root of 75 and square root of 3. So again, to add radicals together, we should have the same number or the same expression under radical. However, we can simplify that. We can rewrite square root of 75. Square root of 75 is the same as, rewrite 75 as a product of 25 times 3, right? Why I picked the 25? Because I know what is square root of 25. So now using the product property, this is the same as square root of 25 times square root of 3. Square root of 25, it's 5, so we have 5 square root of 3. So I'm going to rewrite, again, square root of 75 as 5 radicals of 3. So let's just rewrite this problem. Square root of 75 plus 2 square roots of 3. Square root of 75, it's 5 radicals of 3 plus 2 radicals of 3. And now we can add the radicals together because we have like radicals. Now we have that square root of 3, which repeats in both expressions. So use the distribution property. Move radical of 3, which repeats outside of the parenthesis, and add only coefficients. So we have 5 plus 2. So that will give us 7 radicals of 3. Okay, so we simplify radicals first and then we can add them. Now B, 4 square roots of a square B minus 6a square root of B. Okay, so the same thing, I cannot subtract those expressions because I don't have like radicals. Here, the square root of b, it cannot be simplified. We talked about it in previous section. The index of square root, it's 2. B is being raised only to the first power, so we cannot simplify that. However, we can simplify this. Okay, so let's just work with this first. So we have square root of a square b. So don't forget that it's a product between all of them. You can rewrite that as a square root of a square times square root of b. So again, square root of a square will be a, because if you will change that to exponential, that will become just a to the power of 2 divided by the index, which is also 2. So 2 divided by 2 and square root of b. So that will become a to the first power radical of b, which is just a radical of b. Okay, so this is just a square root of b. So going back, I simplify this. So let's just rewrite that. So we have 4 square root of a square b. It's the same as a square root of b minus 6a square root of b. Now we can subtract them because we have like radicals. They both have square root of b. So use the distribution property, move square root of b outside of the parenthesis, and we will just subtract the coefficients, which is 4a minus 6a. And that will give us negative 2a square root of b. That will be the final solution. And the last problem, last part C of this example, we have negative 3 square root of 2y cubed plus 5y square root of 18y minus 2 square root of 50y cubed. Okay. So here what we need to do, we need to simplify. Like you see, we don't have like terms. Each expression under radical is different. So in order to simplify, we need to simplify each. So first what I'm going to do, I'm going to simplify this one. Square root of 2y to the third power. So square root of 2y to the third power can be rewrite as square root of 2 times square root of y to the third power. Okay. Okay. So here, what we can do with that, y to the third power, the index of square root is 2, so you can rewrite that as y squared times y, and again, originally the power was 3, so I'm missing that 1, because 2 plus 1 will give you 3. Okay, so that will be square root of 2 times, use the product property, which is square root of y squared times square root of y. And square root of y squared is just y. So we have square root of 2 times y times square root of y. So we're going to simplify this expression as, again, y doesn't have a radical, so let's just move that in front. And square root of 2 times square root of y is the same as 2y. Okay, so I simplify this part. So let me just rewrite that. As don't forget that you still have that negative 3 times, and let's rewrite that as y square root of 2y. Hold on. Okay. So next what I'm going to do, I'm going to simplify this. Radical of 18y. Okay, right here. Radical of 18y. So you want to rewrite that as a square root. So let's break down 18 as 9 times 2, and I pick 9 because we know what is square root of 9, and times y. So this is the same as square root of 9 times square root of 2 times square root of y, and that will just give us 3 times square root of 2y. Okay, and we're going to keep it that way. So like you see that at this moment, we know that we will be able to simplify this problem C, but we need to change each radical to have only square root of 2y under only 2y under radical. So here, going back to this problem, that square root of 18y, we're going to replace with 3 square roots of 2y. So let's just continue. So that will be here plus 5y times 3 square root of 2y. Okay. And next what I'm going to do, I'm going to simplify the radical of 50y cubed. Okay. So I'm going to simplify, okay, the radical of 50y cubed. Square root of 50y to the third power. Okay, so let's simplify that. 50, let's rewrite as a product of 25 times 2, because we know what is square root of 25. Y to the third power, you can rewrite as y to a second power times y to the first power. And why I pick y to a second power? Because the square root of y squared is just y. So now let's just break this down as a square root of 25 times square root of 2 times square root of y squared times square root of y. Now, square root of 25, it's 5. Square root of 2, we cannot simplify. Square root of y squared, it's y. So no radical. And square root of y is just square root of y. So now we will end up with, let's move the numbers in front of the radical, which is 5y. You have square root of 2 times square root of y. When you multiply square roots, you're putting them together under square root 2 times y. Okay. Okay. So this is 50y cubed. So let's just go back to this problem and rewrite that 50y cubed. Don't forget that we still have this part, like negative 2. So this is negative 2, and the square root of 50y cubed is the same as 5, so times 5y square root of 2y. And now I'm going to simplify this problem, solve it. So now you see that we have like radicals. Each of the expression has that square root of 2y. So open parenthesis, let's distribute, use the distribution property. Outside of parenthesis, we're going to copy that square root of 2y. And inside of the parentheses, we put in the coefficients, which is negative 3y, then plus 5y times 3, which will give you 15y, and here we have minus, minus 2 times 5y, which will give you negative 10y. Okay, so to simplify that, that will give us, again, negative 3y plus 15y minus 10y. So we have 12y minus 10y, that will be 2y square root of 2y. And that will be the final solution, 2y square root of 2y. Okay, that's the final answer. And one more example. That will be the last one. We have 4 square roots of 45 minus 5, under square root, minus square root of 5y to the 4 power. Okay, so how are we going to subtract those radicals? We need like radicals first. So let me first simplify the expression 4 square root of 45. Maybe just do it the same. Let's just first simplify that square root of 45. 4 means 4 times square root of 45. So that will just become, and break down 45 as one of the numbers. One of the products will be perfect square. So 45 is the same as 9 times 5. And this is the same as square root of 9 times square root of 5. Like you see, I always pick, when I factor the expression or the number under radical, I always pick a perfect square. So square root of 9 is 3. So we have 3 square roots of 5. So here, that first expression, I'm going to rewrite as 4 times square root of 45 is just 3 square roots of 5. And next what I'm going to do, I'm going to simplify the square root of 5y to the 4 power. So this is the same as square root of 5 times square root of y to the 4 power. Okay. So this is the same as square root of 5 times y to the 4 power. You can break it down as y squared times y squared, okay? Using the product property of exponents, so we have the same basis. So to get 4, we're adding exponents. So this is the same as square root of 5 times square root of y squared times square root of y squared. And we're getting square root of 5. Square root of y squared is y. Square root of the other y squared is also y. So we're having y squared square root of 5. Okay. So this expression, okay, we're going to plug in into our original problem. So we have minus y squared square root of 5. And now we can subtract that expression since we have like radicals. Like you see right now, we have the same expression under radical, so we can subtract them, use the distribution property. Outside, move the square root of 5, the one which repeats. Inside of the parentheses, we're putting the coefficient, which is 4 times 3, which will be 12, and negative y squared. So the final answer will be, in parentheses, 12 minus y squared, square root of 5. So this is the final solution. Okay, so that's it from section 18.3. I have one more section for you, which will be the last section of the semester, 18.5, multiplication of radicals. Okay. Thank you for watching.